it. All righty. Okay, so we're in business, y'all. Let's do this. So, y'all, when we were here yesterday, we were talking about inequalities, and we still have a few problems to go through. So let's knock these out and hope that this stuff here, y'all, makes some sense. Okay. So, y'all, I'm just going to rewrite the problem down here where I got a little bit more room. 2x minus 3 less than or equal to 9. Like I said, y'all, when we're solving inequalities, we solve them just like the way we solve an equation. We're trying to get the letter x by itself. So the first thing I'm going to do, I'm going to add 3 to both sides. Okay, those guys are going to go away. Let's see, less than or equal to 9 and 3 is going to give me a 12. Then we're going to go ahead and divide everything here by 2. And we get x is smaller than or equal to 6. Okay, so y'all, the other thing we did yesterday was we would draw a number line, okay? And y'all, again, the more important thing about the number line is that we at least plot this guy here. So let's say, look, here's the number 6, okay? Boom. Y'all, since we have this little line underneath here, that 6, the dot on the 6 y'all is going to be filled in, okay? So if we have the line, we fill it in. If we don't have the line, we leave the little circle open. And then, y'all, since our inequality sign is pointing to the left, then, y'all, we're going to go ahead and shade all of this area right there. And that's pretty much what we're looking for. Okay. So, again, y'all, we had done problems like this yesterday. I wanted to save this one for today just so, again, we'd have a little review-ish, right? Y'all, I'm going to scroll down a little bit further. Now, there is one slight difference, y'all, when we're solving inequalities. And that's what I have written right here. Anytime we multiply or divide by a number that's negative, we have to reverse the direction of the inequality sign, okay? So let me explain what I mean by this, y'all. I'm going to kind of scooch over here to the side, okay? And I'm going to think about a couple of numbers. So first thing I'm going to do, y'all, I'm going to draw my number line here, okay? And like here's 0, here's 1, here's 2, here's 3, 4, and 5. And I'll even put the negative ones over here too, y'all. Okay. Okay, so let's think about a couple of numbers. I'm going to pick a number that's negative. I'm going to pick a number that's positive. So if I were to say pick the number -3 and -3, and I were also to pick the number, say, +2. And I'm going to put one of these signs, y'all, either less than or greater than. So let's make sure that we understand what each of these guys mean. So this is less than, right? Which just means that the number is smaller. And this one here is greater than, and that just means that the number is bigger, okay? So the question I'm trying to figure out is -3, is it smaller or is it bigger than +2? So y'all, when we look at our number line, anytime a number is to the left of another number, this number is going to be smaller. So we would say -3 is smaller than 2. Now, if I were to change this sign and that sign, so instead of this being a -3, if I were to put a +3, and instead of me putting a +2, I put a -2. So notice what we did. We changed the signs, right? Now, if I change the signs, I want to know, is 3 smaller or bigger than -2? Because 3 is over here and 2 is over here. 3 is going to be bigger, right? So, think about it this way. If when we get out of here at noon, if I said, hey, let's go grab a bite to eat, and we eat, and then I'm looking at you and you're looking at me like, who's going to pay the bill? And I said, well, look, I went to the bank this morning and my balance said -3. And you said, well, I went to the bank this morning and my balance said I had $2. And I say, you know what? We don't got a whole lot of money between the two of us, but you got more money than me because you got $2. I got to pay the bank $3, right? And so that's why we say, numbers to the left are smaller, right? So again, when I change those signs here, making this one a +3, making that one a -2, my inequality sign has to change, okay? So that's the rationale behind that. So let me come back this way, and let's take a look at this first problem. So it says negative 3x is greater than or equal to 12. So again, y'all, first thing I'm going to do, I'm going to divide everything by a negative 3, okay? And those are going to cancel. And then over here, y'all, 12 divided by negative 3 is a negative 4. But since we divided by a number that was negative, my inequality sign, y'all, has to change. So instead of it pointing to the right, it now points to the left, okay? And y'all, just like we did earlier, I'm going to draw my number line here. I'm going to put my number negative 4. Boom, there it is. I'm going to go ahead and fill that circle in. And I'm filling it in, y'all, because we got that little line right there underneath. And I'm going to shade in the direction that my arrow is pointing. And so I'm going to shade that way, okay? All right, y'all, I'm going to scroll down to the next one. And I'm going to do the same thing here. I'm going to divide both sides by a negative 4. So that one and that one cancel. Right over here, y'all, we got a 12 divided by a negative 4. That's a negative 3. And again, because we divided by a negative, y'all, that inequality sign is going to switch over, okay? So, y'all, I'm going to draw my number line right here, okay? The number that I'm really interested, y'all, in is negative 3. Now, just a note, y'all, I do not have the little line underneath that inequality sign. So that circle is going to stay open, but I am going to shade it to the right. Okay. So again, just let me kind of zoom out so you can see everything. If we have the little line right here underneath, then we fill that circle in. And if we don't have the line underneath, then we leave that circle wide open, okay? Good, good, good. All righty, let me scroll down a little bit further, okay? And again, y'all, I'm still doing the same process here, okay? So, y'all, just like we did when we had equations, the first thing I'm going to do, I'm just going to draw a line going down this way, okay? And I'm going to go ahead and move my smaller x to my bigger x. So I'm going to go ahead and go minus 2x and minus 2x here. And so 3 minus 2x is an x, minus 5. That's still bigger than negative 8. I'm going to go ahead and add 5 to both sides. Okay. And I'm going to get x is bigger than, let's see, negative 8 and 5 is a minus 3. Now, notice, y'all, I did not multiply nor did I divide by anything that was negative, because the number in front of my x was already a 1. I didn't have to divide or multiply by anything. So my inequality sign doesn't change. I'm going to draw my number line right here. Okay. The number I'm interested in is negative 3. I'm going to leave that circle open. And again, I'm going to shade everything to the right. Okie dokie. So, y'all, in doing these problems here, again, my process is still going to be very much the same. The one thing I'm going to do that I don't necessarily do an equation, but we can. But I'm always going to put my x, y'all, on the left side, okay? Because if my x is on the left side, then I know which way to shade my arrow. So like right here, there's a minus 8x, y'all. I'm going to put a plus 8x. Okay, I'm going to move my x's to the left. So look, we still have a 3. Right here, negative 7 plus 8. That means I owe you $7. I have 8. Still left with 1. Okay, less than or equal to 10. I'm going to go ahead and minus 3 and minus 3. And I'm getting x is less than or equal to 10. 10 minus 3 should just be a 7. And boom, there's my answer. Okay. Again, y'all, I'm going to draw my number 7 right here. I do have the little line underneath, y'all, so I'm going to go ahead and fill that circle in. Okay, so there it is, shaded in. And my arrow is pointing to the left. So, boom, boom, boom. There we go. Okay. All right. Y'all, let me scroll down just a little bit more because we got a few more of these to do. Okay. And what I'm going to do here, y'all, Same sort of process, right? So look, negative 6x plus 2 is greater than, y'all, I'm going to go ahead and multiply that 2 there. So that's at 10 minus 2x. Again, y'all, because I'm dealing with inequalities, I want to get my x's on the left. So I'm going to say, look, let me add this 2x over here. Okay. Those are going to go away. And then right here, y'all, minus 6 and plus 2 should be a minus 4. X plus 2 greater than or equal to 10. Okay. I'm going to go ahead and go minus 2 and minus 2. Negative 4x bigger than or equal to, let's see, 10 minus 2 should be 8. My last step, y'all, I'm dividing by the number negative 4 because that's the number in front of my x, okay? So if we divide by a negative 4, y'all, right here, 8 divided by negative 4 is a negative 2, but my inequality sign, y'all, it's got to flip back over, right? Because we divided by a number that was negative, okay? Again, y'all, I'm going to draw my number line. Here it is. I'm going to put my number right here, negative 2. I'm going to fill that circle in because we got the little line there. All right, we got this little line, so fill it in. And if I'm pointing to the left, I'm going to shade to the left, right? All right. So, y'all, the second part I have here dealing with inequalities are these things called compound inequalities, okay? And the directions that I have for this problem, y'all, and I'm going to check something real quick, guys, in my Blackboard class, because I know I gave us some problems dealing with inequalities, and I have some directions here, and usually we do that kind of stuff like in a college algebra class with part of the direction, and I'm curious if I have that included here. Let's see, inequalities. Okay, let's take a look. See here. Oh man, I don't know. I'm going to try to go like to 11 or something. I'm just curious if I put that in here too. Okay, so inequality. Boom. Inequality. Okay, what about 14? Inequality. Okay, what about 16? Okay, so they do want me to write some interval notation here. Okay, so we're good. We're good. We'll do it. It's not a big deal. Okay, so it looks like it's just the last two problems where we're actually going to do a little bit of interval notation stuff. Okay, I don't think any of the other ones had me do. Yeah. Okay, so it's fine. It's all good. So y'all, I'm going to show you something now called interval notation or interval form. They both mean the same thing. Okay. So y'all, when we have this kind of a compound inequality, what I'm trying to do is I'm trying to get one number here and then maybe less than or equal to x, and then another number right here. Okay, so the main thing is I'm trying to get the x by itself in the middle. So right here, y'all, if I see a minus 4, I'm going to go ahead and go plus 4, but I got to do it on 3 sides, on the left, in the middle, and on the right. Okay, so let's see what's going to happen here. Negative 3 and 4 is a positive 1. Those 4s are going to cancel. That's an x. 8 and 4, y'all, is going to give us a 12. Okay. Now, I'm going to show you guys something. I'm going to draw my number line here, okay? And the two numbers that I'm really interested in putting you guys on here are the numbers 1 and the numbers 12. Now, first thing I notice, I don't have the little lines underneath. So the circles here, guys, are going to be open, okay? The second thing is, since my x is between those two numbers, what I'm looking at here, y'all, is I'm looking at shading everything between those two numbers, okay? So again, there's my graph. Now, y'all, I'm going to show you something called interval form or interval notation. Interval form just says, hey, when we started shading this thing, where did we start shading at? Oh, we started shading at 1. Where did we stop shading at? Oh, we stopped shading at 12. Now, if those circles are open, y'all, what we use is we use round parentheses, okay? Let me make sure that looks like a round parenthesis here. Boom, like that. And I'm going to show you guys on the next one, because I don't know if I put it on this one. I'm trying to see if I have one where I have the little equal to. I don't, but I'll put one on, like I'll do the next one. I'll put the little equal to lines underneath, and I'll show you what do we do when we do have the little lines there, okay? When we don't have the lines, y'all, when the lines are open, we use parentheses, okay? So let's do this for the next one. On the next one, y'all, I'm going to change the problem slightly. I'm going to put a little line here, and I'm going to put a little line there, okay? I just want to change it up a little bit, all right? Y'all, I'm going to do the same thing here. I want to get the x in the middle by itself. So there's a plus 6 right here, y'all. I'm going to put a minus 6 all the way across, okay? So on this side, y'all, minus 4 minus 6, that's going to give me a minus 10 less than 2x less than or equal to 14 minus 6, y'all. That's going to be an 8. Okay. My last step, y'all, I'm going to go ahead and divide everything here by 2. Okay, now it's a positive 2, y'all, so my inequality signs aren't flipping or anything. Okay, and let's see, negative 10 divided by 2, negative 5, less than or equal to x, less than or equal to 8 divided by 2 is a 4. Okay, so let's draw the graph first. So here's my graph. Okay, the two numbers that I'm really interested in putting on here, y'all, are negative 5 and 4. Okay, now again, I do have those little lines underneath, right? So y'all, if I got the little lines underneath, I'm going to go ahead and fill in this circle here, and I'm going to fill in this circle here, okay? And again, since the x is in the middle, I'm shading everything here in the middle, okay? So now, how do I write my interval form? We say, look, where did we start shading at? Oh, we started shading at negative 5. When did we stop shading? We stopped shading at 4. Now, since we do have those little lines, and because those circles were filled in, what we use, y'all, we use square brackets, okay? So when the little lines aren't there and the circles are open, we use round parentheses. If the little lines are there and the circles are filled in, we use brackets, okay? Okie dokie. So let me scroll down a little bit more. And y'all, for this next one here, the first, I'm going to change this problem slightly also, y'all, because again, I just want to make sure that we're all good with this. I'm going to put a little line, boom, underneath that 5, okay? So I'm going to go ahead and draw the little line right here underneath the 5, only on the 5 though, okay? Not in front of the other one. Y'all, when I have a problem like this that has fractions, I'm going to do this like the way we did the problems yesterday, where we said, look, if I have an inequality with fractions, I'm going to think of my common denominator. So look, y'all, I have 1, 2, 1, and 1. So let me come back this way, right? And let me scroll down. Let me find my multiplication table, okay? And let me take a look at this guy here. So y'all, the two denominators that I have are 1 and 2, okay? So if I look at 1 and I look at 2, the first number that they both have in common, y'all, is the number 2. Okay, that's going to be my common denominator. So y'all, I'm going to go like this. Brackets around the whole thing, right? We're going to go 2 over 1. Okay. Y'all, I'm going to go really slow here. So I'm going to say, look, 2 times negative 3, negative 6. Less than 2 times 1, 2 with an x. Okay. 2 times 1 again, another 2. Remember, I put that little line underneath y'all, so I'm keeping it there. 2 times 5 is going to give me 10. Now, the bottom numbers, y'all, the bottom numbers don't change. That stays as a 1, that stays as a 2, that stays as a 1, and that stays as a 1. But if we did this right, y'all, all of our fractions are going to go away. Negative 6 divided by 1 is negative 6. This 2 and that 2 are going to cancel. That's just an x. 2 divided by 1 is still 2. And 10 divided by 1 is still 10. Okay. So right here, y'all, I got negative 6 less than x plus 2 less than or equal to 10. Okay. Let me go ahead and go minus 2 here, minus 2 here, minus 2 here. So right here, y'all, minus 6 minus 2 is a minus 8. Okay, those 2's cancel. 10 minus 2 is a positive 8. Okay. Now I'm just going to scroll over, y'all, where I got a little bit of room. Okay. And I'm going to draw my number line. Okay. Now, remember, y'all, on the number line, the two numbers that I'm interested in writing down are -8, +8, right? So if you notice here, y'all, the -8, I don't have the line there, so I'm going to leave that one open. At the +8, I do, so I'm going to go ahead and fill this guy in, okay? And then since my X is in the middle, y'all, we're looking at everything in the middle, right? So we can say, where did we start shading at? Hey, we started shading at 8, or -8, I'm sorry. Where did we stop? Oh, at +8. Because this has an open circle, I'm going to go around parentheses. Because that circle is filled in, I'm going to use the square bracket, okay? So when you get a question like this, y'all, one of them may have the line underneath and one of them may not. Neither of them may have it, or both may have it, okay? But wherever you don't have it, use the parentheses. And wherever you do, you fill in the circle and we use the little bracket, okay? So let's do this, y'all. Let's try this next one here. Oops. Let's try this next one here. And again, I will just kind of go through the process, all right? So look, y'all, first thing I'm going to do here, come on, pen, there we go, is let's multiply by 2. So -8. 2 times x is a 2x. 2 times 1 is a +2. Oops, no little line underneath. And that was a 15. Okay. All right. So again, y'all, I'm going to go ahead and get rid of this 2 here by going -2, -2, -2. Okay. So that's a -10 less than 2x less than 15 minus 2, y'all, is 13. Okay. And then I'm going to go ahead and divide everything here by 2, y'all. So let's see, -10 divided by 2, -5, okay, less than x, less than, y'all, I'm just going to leave that as 13 over 2, because I know 2 doesn't go nice and pretty into 13. Okay. Again, y'all, here is my number line. Here's my number -5. And here's my number 13 over 2. Okay. Y'all, neither of them have the little line underneath, so both those circles are going to stay open. And we're just going to shade everything here in the middle, okay? And then, y'all, in interval notation, we're going to go -5 to 13 over 2, both with parentheses because both circles were open. All right. So, y'all, let me scroll down a little bit further, and we got one more to do here with inequalities, and then we can go ahead and move on to exponents and that kind of stuff. Y'all, I'm just going to rewrite the problem here just so I have a little bit more room. X plus 1 less than 7. Okay, so y'all, just like the problem before this, which was, yeah, this guy right here, since we had fractions, y'all, we got fractions again, right? So let's do this. Let's think of this guy over 1, this guy over 1, and this guy over 1. So y'all, I'm looking at two numbers. I'm looking at 1 and I'm looking at 4, right? Those are the two different denominators that I have. So y'all, if I come back to my multiplication table, here's the number 1, here's the number 4. The first number they both have in common, y'all, is that 4, right? So look, y'all, we're going to put brackets here and brackets here, and we're going to multiply everything by 4 over 1. 1, 2, 3, and 4. Okay. So I'm going to say 4 times -2, -8. Less than 4 times 3, 12 with an x. Plus 4 times 1, 4. Less than 4 times 7, let's go 28. Okay. All right, remember the bottom numbers, y'all, get multiplied by 1. So this stays a 1, that stays a 4, that stays a 1, and that stays a 1. Okay. Y'all, but if we did this right, our fractions are going to go away. -8 divided by 1, -8. 12 divided by 4, 3. 4 divided by 1, 4. 28 divided by 1, still 28. Okay. Let's go ahead and go minus 4 all the way across. So let's see, minus 8 minus 4, y'all, that's going to leave me with a negative 12 less than 3x less than 28 minus 4 is 24. And then we'll divide everything here by 3. So negative 4 less than x less than 24 divided by 3 should be 8. Okay. All right, so y'all, here's my number line. Okay. Here's my number negative 4. Here's my number 8. Since I don't have the lines underneath, y'all, those circles are staying open. And I'm shading everything in the middle. And again, because those circles are open, y'all, I'm using my round parentheses, right? And there you go. So, y'all, this part here, this was what we were, what I needed to finish from yesterday. So, again, we got the inequality stuff done. Very similar to solving an equation, y'all. The difference here, the main difference here is, like I said, there's a bunch of answers that there's actually a whole bunch of numbers that work for that inequality. To give you, again, an idea, what numbers are we looking at? We're looking at all the numbers between negative 4 and 8. So what I mean by that, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. But not only those numbers, numbers like 2.3, negative 2.9, 7.9, 3.5. There's a whole bunch of numbers there between negative 4 and 8. There's actually an infinite amount of numbers. So again, the difference between an inequality and an equation, at least for the purposes we've been doing them, have one answer. Inequalities, there's a bunch of answers there, right? But this is how we write all those answers together. Okay. Okay, so y'all, the next part here, let me see if I can fix this a little bit. Boom, boom, boom. There we go. Okay, is dealing with exponents, y'all. So again, we've talked a little bit about exponents. It's not like we haven't talked about exponents before. So y'all, like if I'm looking at this one, 7 squared, remember what that means? It means 7 times 7, which is 49, right? Y'all, the main thing I want to point on here about the exponents is problems that look like these, okay, like the next two. And we can see that there's a difference in those two problems. This one has parentheses, this one doesn't. So y'all, when I have parentheses, I'm going to write the number that's inside my parentheses as many times as my exponent tells me to do that. So if it's negative 3 in parentheses, I write my numbers in parentheses and I say negative 3 times another negative 3 is a positive 9, right? But this guy, y'all, does not have parentheses. So when I see something like this, the 2, y'all, is only for the number 3. It is not for the negative. That means I write the negative once. But then I write the number 3 twice. And I say, look, I know what 3 times 3 is. 3 times 3 is 9. But because of this, that makes it into a negative 9. Okay. So if I don't have parentheses, y'all, the exponent is only on the number. And the negative is just written down just that one time. Okay. All right. Y'all, when we're doing these kind of evaluating problems, when we're going to do our plug and chug, we're always going to use parentheses here, okay? So it says x to the third. So where my x used to be, y'all, I'm going to put negative 2 to the third power, okay? So first thing I want you to notice, we do have parentheses. So y'all, I'm going to write the number negative 2. I'm going to write it down 3 times. Why 3 times? Because that was the power we had, okay? So look, let's multiply these guys together. Negative 2 times another negative 2 is a positive 4. And then 4 times negative 2, y'all, boom, minus 8. Okay. All right, the next one here says 5x to the third when x is equal to 3. Okay, I'm going to do the same thing. Come back here, I'm going to write 5, 3 to the third power. So where they put the number 3, and that 3 was already there. Okay, remember what this means. 5 times 3 times 3 times 3. Okay, y'all, we're just multiplying here. So when we multiply, it doesn't matter which numbers we multiply first or second. Okay. I know that 5 times 3 is 15. And I know that 3 times 3 is 9. So now I want to figure out what's 15 times 9, 135, right? Boom. And there we go. Okay. All right, let me keep scrolling down here. Okay, so y'all, the next part we have here is this idea. There's something here, guys, called the product rule. Okay. And the product rule for exponents, y'all, says if we're multiplying two numbers that have the same base, so they're either both x's or both y's or both sevens, it really doesn't make any difference. But what we're going to do with the exponents, y'all, we're going to add them together. Okay. So if I have x squared times x to the fifth, y'all, my answer is going to be x to the power 7. Now, that's what the rule says, but I want to make sure that we understand why is that the rule. Okay. Look, y'all, if I got x squared times x to the fifth, remember what x squared means? It means that there are two of them, right? What does x to the 5 mean? It means that there's 1, 2, 3, 4, 5 of them. And if I'm just multiplying all these guys together, and I got 1, 2, 3, 4, 5, 6, boom, 7, right? And that's why the rule works the way it does. Okay. Let's take a look at the next one here. We got y squared times y. So, y'all, one thing I want to mention here, like there's two y's right here. When I look at this one here, if I don't see the power, y'all, there really is one of them. Okay. So now, if I got two y's here and one more, now we got a total of 3. Okay. All right, let me scroll down a little bit more. Y'all, for something like this, what I'm going to do, I'm going to multiply my numbers together. So 5 times 3, that's going to give me 15. 4 y's and one more is going to give me a total of 5. Okay. Again, if I don't see the power, y'all, it's always understood to be the power 1. Okay. Right here, y'all, -2 times another -2, +4. I got 3 z's right here. I got another 2 z's right there. So we should have a total of 5 of them. Now, again, y'all notice I'm writing those 5s as my exponents, right? So it's the power of 5, okay? All right, let me keep scrolling down here. And let's put our x's together. And let's put our y's together. So x to the 9th and x to the 10th, y'all, that's going to give me 19 x's. Remember, there's one y right there. One y and another 5. That's got to be a total of 6. Okay. So again, I'm just adding my powers together, okay? 9 and 10, 19. 1 and 5 gives me 6. Okay. Now, the second thing I have here, y'all, is something called the power rule. The power rule says, what do we do when we have a power that's being raised to a power? And what we do, y'all, with those exponents is we multiply them, okay? So 9 times 4, y'all, is going to give me 36, okay? Right over here. 7 times 5, y'all, is going to give me 35, okay? So again, I'm just multiplying the exponents. If I have a power raised to a power, that's when we can multiply our exponents together, okay? Let me scroll down a little bit more. So y'all, I got a couple more problems here. So again, first thing I want to do is on the inside of those parentheses, y'all, the power in my P and the power in my Q really are 1s. So what am I going to do with that 8? I'm going to multiply that 8 times each of those 1s. Well, 1 times 8 is still 8. And 1 times 8 again is still 8. So I got P to the 8th and Q to the 8th. Okay. Y'all, for something like this here, 2a to the 5th, all raised to the 3rd, let me just explain what that means. It means 2a to the 5th, 2a to the 5th, and another 2a to the 5th, right? That's what it means to raise something to the 3rd power. Okay, so a couple things we can do here. We can say, look, let's multiply our numbers. 2 times 2 is 4, times another 2 is 8. If I got 5 A's here and I got another 5 A's there, that's 10. And if I got another 5 there, y'all, that's 15. Okay. So let me see, how can I get my answer from here to there? Well, I'm still going to multiply my exponents. 5 and 3, still going to give me 15. But my number, y'all, my number is 2 to the third. That means that I have to multiply that number by itself 3 times. Okay, so again, for the number in front, there's no real shortcut. You still got to multiply it by itself as many times as we do it, right? So like right here, we said 2 times 2 is 4. 4 times 2 is 8. And that's why we got that 8 right there. Okay. All right, let me scroll down a little bit more. Okay, y'all, I'm going to do the same thing here with this next problem. Okay, let's do it like this. Remember, the power of my C, y'all, inside really is a 1. Okay, so look, we're going to multiply. 1 times 2 is 2. 5 times 2 on the power of my B now is a 10. Okay, 2 times 2, the power of my A, y'all, is a 4. Now, there's a -7, and it's in parentheses, and it's being squared. So remember, -7 squared, y'all, really means -7 times another -7, and that's giving me a 49. So we got a 49, a to the 4th, b to the 10th, and a c squared. All right. Y'all, I'm going to scroll down a little bit more because we still got a couple more here with exponents. Y'all, again, just a friendly reminder, if you don't see any powers inside, remember those powers really are 1s. And I'm just multiplying my exponent. So that's r to the 9th. And on the bottom, that's s to the power 9. Okay. All right, same thing here on this next one, y'all. The power in my x and my y really are 2s. So that's going to be x2, and that's going to be y2. Now the bottom, remember, it's not 7 times 2, but it's 7 times 7. And 7 times 7, y'all, should give us a 49, right? So x squared, y squared, all over 49. Okay. Y'all, whenever you're taking tests, just be careful with that. A lot of times with exponents, if people see like a power and they have a number, they want to multiply the number and the power, but it's really you're multiplying that number by itself as many times, okay? All right, so y'all, still a couple more. Let me put the powers here. Those are 1s, okay? So let's deal with our letters first. Y'all, 1 times 2, that's going to give me a 2. 1 times 2 again, that's going to give me another 2. So my x is a 2. The power in my z is a 2. The power in my y, y'all, 2 times 5, that's going to give me a 10, okay? And then we got this -2 being squared. Remember, that means -2 times another -2. That's going to give us a +4. All right. Let me scroll down a little bit more, y'all. Okay, so now we have something called the quotient rule for exponents. So, y'all, the quotient rule for exponents says if you're dividing two numbers that have the same base, so they're both A's, they're both B's, they're both X's, what do we do with the exponents? We subtract them, okay? So look, y'all, if there's a power of 1 on the bottom, and I got an x to the 3, we're going to subtract them. We're going to say 3 minus 1, y'all, is going to give us 2, okay? Now, again, y'all, let me show you why the rule works the way it does. If we have x to the third over x, remember what x to the third means. It means that there's 1, there's 2, and there's 3 of them. This x right here just means that there's 1 of them. Well, guess what? This guy here is going to cancel with that guy there, and we still have 2 of them left over, okay? So again, that's why the rule works the way it does. A lot of times, y'all, when I go through these problems with my classes, I tell my students, ask yourself, where do we have more x's? So if we looked at x to the third over x, we would say, hey, there's more x's on the top than there are on the bottom. How many more on the top? Well, if there's 3 on the top and 1 on the bottom, that means we still have 2 left over, right? So y'all, if I do the same thing here, and I look at, say, the p's, right? We got p to the 7th over p. We have more p's on the top. If there's 7 on the top and 1 on the bottom, we're still left with 6 of them, right? And then when I deal with my q's, I'm going to say, look, there's 20 q's on the top and there's 15 on the bottom. And if I subtract, that means I'm still left with 5 of them, right? Because I got 5 more. Okay. Yo, let me scroll down a little bit more. Okay. And let's take a look at this one here. So let's start off with the y's, y'all. If I look at my y's, I'm going to say, look, there's 3 on the bottom, there's 6 on the top. I'm left with 3 on the top because there was more on the top to begin with. Y'all, I got 2 x's on the top and 2 x's on the bottom. Both those x's upstairs are going to cancel with both those x's downstairs. Okay. Now, the next thing we're going to talk about is, what about the 7 and the 14? Well, look, y'all, we can divide both those numbers by 7. So 7 goes into 7 one time, and 7 goes into 14 2 times. Okay. So we're left with a 1y to the 3rd all over 2. All right, I'm going to scroll down a little bit more. Okay, negative exponents. All right, so y'all, if we were to say, like, what does, I don't know, what does 2 to the power 4 mean? Well, it means 2 times 2 times 2 times 2, right? And we would say 2 times 2 is 4, and that times 2 is 4, and 4 times 4 would be 16. So we know that 2 to the 4th means 16, right? It means we're multiplying the number 2 4 times. What does it mean when we have a negative exponent? It doesn't mean we're going to multiply something a negative number of times, okay? This means, y'all, is if my exponent is negative, what it means is I can write it as 1 over 4 to the 3rd power, okay? So if my exponent is negative, I'm going to move that piece, y'all, to the bottom part of my fraction. Okay, I'm going to move it downstairs, and my exponent's going to become positive. And then I'm going to say, look, 1 is still 1. But what does the 4 to the 3rd mean? It means 4 times 4 times 4. So 4 times 4 is 16. And 16 times 4 should be 64. So 4 to the negative 3 really means 1 over 4 to the 3rd. And 4 to the 3rd is 64, so it's 1 over 64. Okay. So, y'all, if I have a negative exponent, the way I make that exponent positive is I move it to the bottom part of my fraction. And in case you're wondering, like, hey, I didn't see a fraction the first time, we can think of that being over 1. And all we did is move this guy, boom, downstairs. Okay. Yo, for the next one here, this 7x to the negative 3, I'm going to do the same thing. I'm going to write it so that I only have a positive exponent. So look, y'all, the power in my 7 is not negative. The only thing that has a negative exponent is the x. So I'm going to move this guy down to the bottom, and we got 7x to the 7 over x to the 3. Okay. The only thing I'm moving are my negative exponents. The power in the 7 wasn't negative. If it was, y'all, it would have been like this, because then everything would have been negative. Okay. But since we didn't have that, that's all we're moving. Okay. Y'all, for these next two, I want you to notice where the exponent is. It's on the bottom and it's negative. Well, y'all, if it's on the bottom, what we're going to do, we're going to move it to the top. Okay. So we're going to say that's p to the 3rd over 1. And y'all, if it's over 1, we don't need to write the 1. We can just write p to the 3rd. Okay. So the name of the game here, y'all, is if I have a negative exponent, I'm going to ask myself, where is it in regards to a fraction? Is it on the top? If it's on the top, I'm going to move it to the bottom. My exponent becomes positive. If it's on the bottom, then I'm going to move it upstairs. So again, y'all, same thing here. I'm going to move this guy up to the top, q to the 5 over 1. But again, if it's over 1, y'all, we can just write q to the 5th. Okay. Yo, let me scroll down a little bit more. Okay, we got a couple more to do, so let's knock these guys out and hopefully make some sense in it. Okay. First thing, this guy is negative and it's upstairs. Boom, we're going to move it to the bottom. P over P to the fifth. And then second thing, y'all, this guy is negative and it's downstairs. So we're going to move him to the top. So Q to the 4 over P to the 5. Okay. Okay, for the next one, y'all, first thing I'm going to do here is I'm going to say, look, this X already has a positive exponent, so I'm not going to mess with it. But this guy needs to come downstairs, okay? Now, y'all, I'm going to be left with a 1 at the top. And if you say, where does that 1 come from? Y'all, the number in front of that X squared really is a 1, okay? Let me go like this so you can see it. The 1, it really is a 1, so that's where that 1's coming from. Now, what we're going to do is we're going to say, look, 1, there's an X here, there's 2 more here. I now got a total of 3, and they're all in the bottom. Okay. All right, let me move a little bit more, and let's see what we got over here. So this guy, y'all, same thing. I'm going to leave this Y alone, but I'm going to move this guy up to the top. So I'm going to put a Y to the third right there. Again, I'm left with a 1 on the bottom. Okay. Now, if there's 1 Y here and there's 3 Y's here, y'all, I got a total of 4. If I have a 1 on the bottom, y'all, we don't need to write the 1. So we're just going to leave it as Y to the power 4. Okay. Alrighty. Let me scroll down a little bit more, see what else we got here. Okay, so we got a couple more here with X's. Let's see, how many X's do we have on the top? Look, y'all, if there's 2 and there's 5, that means there's 7. But we have 3 on the bottom. So I'm going to ask myself, okay, where do I have more X's? It looks like we got more on the top. How many more on the top? Looks like we got 4 more, right? Because 7 minus 3 is going to give me 4, right? Y'all, I'll do the same thing here with this next one. Look, we got 4 Y's and another 5. Hey, we got a total of 9. And then there's a Y to the 6 on the bottom. So where do we have more Y's? We got more on the top. And if there's 9 here and there's 6 there, we're still left with 3 of them. Right? Okay. All right, let's see what else we got here. Okay, so we got a couple more. And let's try this next one. Okay, so y'all, first thing I want to look at is I want to look at this piece right here. Now, again, you'll remember that means we got a power raised to a power, right? So we have a power raised to a power, y'all. We're going to multiply those numbers. That's going to give me X to the 16. There's still another X here, and there's still 9 of them on the bottom. Okay. Now let's see. We got 16 X's here, and we got one more. Y'all, we got a total of 17 X's, right? Okay. And now I'm going to say, look, if I got 17 X's on the top and I got 9 X's on the bottom, I have more X's upstairs than I do downstairs. And how many more do we got? We got 8 more, right? Because 17 minus 9 should leave us with 8. Okay. All right. Let's see, y'all. I think there's another one down here. Yes. Okay. So let's do this one, y'all. First thing I'm going to do, I'm going to look at my B's. Okay. And I'm going to ask myself, okay, how many B's do I got on the top? 1. How many B's do I have on the bottom? 2. Y'all agree we got more B's on the bottom than we do on the top? Okay, so y'all, I'm still going to subtract, but I'm going to say, look, 2 minus 1 is 1. But because there were more on the bottom, y'all, that B is going to stay on the bottom. Okay. Now, let me look at my A's. We got 6 A's on the top, and we got 1 A on the bottom. So I have more A's upstairs than I do downstairs. And if there's 6 on the top and 1 on the bottom, still left with 5 of them, y'all. Okay. Now, in regards to my numbers 24 and 6, y'all, we can divide both those numbers by 6. So 6 goes into 6 once. So look, there's my 1B. And 6 goes into negative 24 negative 4 times. Y'all, you don't have to put the 1 on the bottom if you don't want to, but the B's got to stay there for sure. Okay. All right, I'm going to scroll down a little bit more. And let's take a look at this one. So y'all, let's do the same thing we did before. Let's take a look at our x's. Let's take a look at our y's and our numbers. I'm going to start with the y's, y'all. 5 on the top, 2 on the bottom. I'm left with 3 upstairs because there was more upstairs. Y'all, my x's, there's 4 on the top, 4 on the bottom. They're just going to cancel out. Okay. Now, we can divide both those numbers by 5. So y'all, 5 goes into 15 3 times. That 3 is going to be on the bottom. 5 goes into -5, y'all, -1 times. So I got a -1y to the third all over 3. Okay. All right, let's keep moving down here a little bit more. Okay, so y'all, let's do a little bit of polynomials and then we'll take a little break and we'll come back and finish the rest of it, okay? So introduction to polynomials. Y'all, we've talked about like terms before. So we already know how to combine like terms. We're going to say, look, 7x squared and 9x squared, they're both x squared. So we can combine those guys together. So 7 and 9, y'all, should give me something like 16. That's still an x squared. And then a +3 and a -10. So if I had $3, but I owed you 10, and I gave you the 10, I would still owe you 7. Okay. All right. So y'all, for the next part that we got here, let's take a look at this one. Excuse me. 8x squared and 11x squared. 8 and 11, y'all, that's 19. Okay. And then right here, a +4 and a -20. So if I had $4, but I owed you 20, and I gave you 4, I would still owe you 16, right? All right. So y'all, I'm going to scroll down a little bit more. And we want to see if we can find the perimeter. Remember what the perimeter means, y'all? Just the distance all the way around. So I'm going to start walking this way and 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 back up. Okay, so look, let's start writing it. We're going to go 5x plus this side, 7x plus this side, 3x plus this side, 6 plus that side, 2x plus this side, 3 plus this side, 4x plus that side is 3. So all I'm doing, y'all, I'm just adding them all up. Now I'm going to go ahead and combine my like terms. So 5 and 7 is 12. 12 and 3 is 15. 15 and another 2 is 17. And 17 and 4 more should be 21. And then 6 plus 3 is 9. And 9 plus 3 all is 12. And again, all we did is we just combined our x's and we combined our y's. Y'all, again, for something like this, you can always definitely use, let me bring this down a little bit. Let's go this way. Let's see. Okay, for something like this, guys, you can always use your calculator, right? So if you want to, you can say, look, I'm thinking about just the x's. 5 plus 7 plus 3 plus 2 plus 4. Oops, not 5, but 4. 21. There's the number in front of my x, right? And then we can say, look, 6 plus 3 plus another 3, 12. There's the number by itself, right? So that's really all I'm doing there. Okay. Okay, so y'all, adding and subtracting polynomials. When we add or subtract polynomials, y'all, all we're doing is we're combining like terms. I always tell my students, y'all, if the problem says add, I'm going to rewrite the problem, but I'm going to drop all of the parentheses. So I'm just going to rewrite like this, but I'm not going to put any parentheses there. The next step, y'all, I'm just combining like terms. So 3x and 9x is 12x, plus 7 plus 5, again, plus 12. Okay. So if I'm adding polynomials, y'all, I just rewrite the problem again without any parentheses and combine like terms. Okay. So look, let's try the next one. We're still adding here. Y'all, I'm going to rewrite the problem. 3x minus 8 plus 4x squared minus 3x plus 3. Okay, I'm going to combine like terms. Y'all, the only x squared I see is that guy. So I'm just going to write them down. 4x squared. Now, right here, we got a 3x, and right over here, we got a minus 3x. So if I were to combine those, y'all, they're going to cancel out because one's positive 3 and one's negative 3. So I'm going to get rid of this guy and get rid of that guy. Okay. Now, we have a negative 8 and a positive 3. So remember what negative 8 means. I owe you $8. Positive 3 means I have $3. So if I give you the 3, I still owe you 5. So 4x squared minus 5. Okay. All right. Y'all, I got one more, very much same type of problem. Okay. And again, y'all, because I'm adding, I'm going to drop my parentheses. Okay, so first thing I'm going to do, I'm going to start combining my like terms. This guy here and this guy here, they're both y squareds. Okay, let's combine the numbers in front. Negative 3 plus 2. Remember, if I owed you $3 and I only paid you 2, I would still owe you 1. So it's a minus 1, right? Okay. Now, let's go to the y's. A minus 4y and a plus y. Y'all, if it helps, put the little 1 in front of there so we know the number there is a 1. Okay, so look, we got a y now. Negative 4, positive 1. That means I owe you $4. I only give you 1. I still owe you 3. Okay. And then at the end, y'all, I'm just going to bring down this minus 1 because there's nothing for me to put with it. So we're going to just stop right there. Okay. So if I'm adding polynomials, y'all, I just drop the parentheses, combine like terms. Okay. Now, for the next couple problems, y'all, we are subtracting polynomials. Okay, very similar. The first part, y'all, is still going to be the same. Okay. I'm still going to drop my parentheses, 2x plus 5. Okay. On the second one, before I drop my parentheses, y'all, I'm going to change the signs inside those parentheses because there is a minus sign right here. So if I look inside those parentheses, y'all, inside the parentheses, that 3 is positive. I'm going to change it to a negative 3. Inside the parentheses, y'all, that 9 is negative. I'm going to change it to a positive. When I'm subtracting, I'm changing the signs of everything inside the parentheses over here. So again, y'all, just to make sure that we're okay, the sign of that 3 right there inside the parentheses was a positive, so I made it a negative. The sign of that 9 was a negative, so we made it a positive. Okay. And so the next part here, y'all, we got, let me get rid of this guy. Boom. Yeah, we can leave that. That's fine. Okay. So let's get rid of that too. Okay, let's come back over here. All right, so y'all, let's start combining our x's. So look, those are both x's. 2 minus 3. I have $2. I owe you 3. I still owe you 1. 5 plus 9. Boom, plus 14. And we're done. Okay. All right, let me try another one like that, y'all, just again to make sure that we're good with these things. So remember, the first problem stays the same. Oops, sorry. First part stays the same. 5x squared plus 4. Okay. Now, inside the parentheses, y'all, those signs are going to change. If I notice right here, that is a negative 2y squared. I'm going to write a positive 2y squared. That is a positive 4. Y'all, I'm going to write a minus 4. Okay. Now, y'all, for this problem, I want us to be careless, right? Because if you notice, this is an x squared and that's a y squared. Y'all, I cannot combine them together because they're not like terms, right? One's x's, one's y's. So I'm just going to write 5x squared plus 2y squared. But, y'all, look, positive 4 minus 4, those are going to go away. So, again, that's all we're left with, right? We're just left with that piece right there. All right, guys, I'm going to scroll down a little bit more. And let's take a look at this next one here. So remember, y'all, the first set of parentheses, we just dropped them. Negative 7x squared plus 4x plus 7. On the inside, y'all, those signs are going to change. If it's a minus 8x, I'm going to put a plus 8x. If it's a positive 2, boom, I'm going to put a minus 2. Okay. Now, y'all, I'm going to start worrying about combining my like terms. Okay, x squared, that's the only one we got. So negative 7x squared. Okay, 4 and 8. 4 and 8, y'all, that's going to give me 12x. Okay. And then right over here, plus 7 and minus 2. If I have $7 and I owed you 2, I'm still left with 5. Okay. So it's a plus 5. All right. And y'all, I'm going to scroll down one more time. Okay. And this one here says add or subtract as indicated. Y'all, let's do this. For this particular problem, let's pretend that this guy is not even here for right now. Okay. I'm just going to pretend that's not even there. Look what we're doing here. We're adding. So what does that mean I'm going to do? I'm just going to drop my parentheses, y'all, and I'm going to combine my like terms. Okay. So let's do that. Let's see what we got. 2x squared and another x squared. Boom, that's 3x squared. Y'all, again, right here, look, 7x, this is a minus x. Y'all, if it helps, think about that as a minus 1. So that means I have $7, but I owe you 1. Well, I'm still left with 6. Okay. And then my numbers, a minus 9 and a plus 10. I owe you $9, but I have 10. Still left with $1, right? Okay, now, as much as I wish we could just say, oh, that's not there, we can't, right? It's still part of the problem. Because we're subtracting, y'all, I'm going to change the signs inside my parentheses. Inside this parentheses, that's a positive 3. So look, y'all, we're going to put a minus 3. Inside the parentheses, that's a minus 30. Y'all, we're going to put a plus 30. Okay. So now I'm going to keep combining 3x squared minus 3x squared. Y'all, those x squareds are going to go away. Okay. So let me bring down my 6x because I don't have any other x's. And then a plus 1 and a plus 30. That should be a plus 31. Let's see. Questions? Okay, somebody else got questions. Okay, not in our class. That's okay. It's fine. Okay, guys, let's take a little break and we'll come back because I believe, let me come back down this way. I believe the last thing we got to do today, y'all, is doing multiplying polynomials. Okay? And we still got some good time. So look, guys, let's say at 11:15 we'll come back, okay? So y'all, I'm going to stop record. I'm going to leave the session. I'm going to end it for everybody, but I'll join back in, y'all, at 11:15, okay? So let's go like that, leave, end it.